Okay guys, so in this video I'll introduce Numpy. Numpy is a very important package in Python. It is used for advanced scientific and mathematical calculations. Now if you don't have Numpy, you can download and install it using this link. But since we're using Google Colab, it's already installed. If you're using an IDE, there's the installation is pretty straightforward. IDEs usually have a link to a way to install packages very easily. So when you when you want to use NumPy in your Python program, you have to first import it. So for those of you who are not familiar with the import function, it's just basically a way to import a Python program into your own program. So the syntax is that import is a Python function, whatever you want to import. So this is the NumPy library that we are importing into our program so that we can use its functions. And as is used just to choose a convenient name or convenient shorthand for the library that you're using. So the convention is NP. So we're going to use NP for NumPy. So whenever we're going to type NP, Python knows that we are using NumPy. Now let's look at data types in NumPy. It has different data types. Boolean means true or false, and another data type is integer, right, 64-bit, and there's a huge range for that. And float 32 is single precision float, and float 64-bit is double precision. Another data type is object, which can be a string or a mixed type of these data types. There are more details. There are more details to the data types. You can use this link to take a look at that. Now, when we are working with arrays, we need to obviously perform array operations. So there are different types of operations in arrays. You can, for example, there are operations to determine the size, shape, memory consumption of arrays, data types of arrays. Indexing is the process of getting and setting the value of individual array elements. So we'll see what that means after a few slides. So it's just extracting out the elements of an array, and slicing is basically getting sub arrays from a larger array. And reshaping, sometimes we need to change the shape of arrays, as we'll see later on. That's also an array operation. And joining, and as the name suggests, these are obvious. You need to sometimes join arrays or split arrays into sub arrays. Now let's look at a simple example. This is a simple array. We first import NumPy into our program, and then this is an array of integers, right? We're just calling that array1. So again, the syntax is np.array. So this is the NumPy function that we're going to use, or you can also call it a NumPy method. And so when you so you have to follow the syntax where you have parentheses over here, square brackets over here. So this is like a list. So now we have like a 1D array. So this is 1D, and you can also see that it has 1 rows and 1, 2, 3, 4, 5 columns. Here is another example of an array. So this is again that function that we are using, np.array, and within the parentheses we have a list of lists, right? So NumPy is going to convert this into a NumPy array, and you can see that this is like a 3 by 3 array. So it has 3 rows and 3 columns, and so we call it a 3 by 3 array. Now let's look at simple operations of arrays. Let's say that we have 2 arrays. This is again an array of integers. Both of these are arrays of integers. You can add them up using the plus sign, subtract them, multiply them, and you can also square root. So there are some basic functions that you can use. The np.sqrt is the square root, and you can also perform other operations to check, for example, the minimum of the array. So array 1 has the minimum value 10, and you can also do max array, like array 1.max. You can also do that. You know, go ahead, type it in, and that should give you 40, right? And we'll continue looking at different operations as we move on. There's a useful function in Numpy which is called arange. So it can give you a range of numbers from a starting point to a stopping point. You can also give it a step and the data type that you're using. So here is an example of how to use arange. So this is again the starting point, this is stopping point, this is where this is the step, and this is the data type that you want the array to be composed of. So this goes again. Python never reaches this number. So this is typical Python behavior. So you'll stop one step before that. So you stop at 23. So it goes from 3 to 23, and you can see there is a step of 2. Now, if you don't give it any initial starting point, it's going to start from 0. And this is just to illustrate that you can also change the data type to float. So this is going to give you numbers from 0 to 6, and each number is going to be a float. Another interesting function is linspace. Now linspace is it's basically divides it basically gives you a range of numbers from like a starting point to a stopping point. And let's say you want to divide this interval into a particular number of segregations. Linspace is going to do that. So for example, this in this case you want 9 numbers. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Between the numbers 10 and 20. So it's going to start from 10, and it's going to automatically basically segregate the numbers, calculate the spacing it wants for the segregation itself. So this is useful when you're plotting, and we might use it later on when we plot using matplotlib. So now here is a case where you want to, let's say, maybe plot get a range of numbers from 0 to this is sine of pi by 4, right? And you want 20 numbers, right? So Python is gonna basically just give you 20 numbers with with the interval that it calculates itself that are going to be between 0 and sine pi by 4. Okay, so if you let's say have an array of numbers, right? We've seen this, and p.array creates an array of numbers. You can also change the data type by using the type parameter, and if you change that to float 32, it's going to give you so now you can see that Python or Numpy has added decimal places, so these are not integers anymore. They're floating or real numbers, or floats as we call them in Python.